all, my name is Vaishali Deshwal and currently I'm working as an assistant professor at Akgec. Today is the second lecture of blockchain architecture design and the code for the subject is BCS 063. So today we'll discuss these topics. It's a part of unit 1. Underlying key tech behind the blockchain. Second topic is limitation and third is about the difference between blockchain and database. Then fourth is about history of blockchain and digital money to distributed ledgers. So in the very first lecture of blockchain, we have covered the basics, certain terminologies related to blockchain, and today I'll discuss the challenges, the difference between the traditional databases and the blockchain, and little bit about history and digital money to distributed ledger, and how the digital money is transforming, or what is the journey from digital money to the distributed ledgers. Okay, so this diagram, by this visualization, we can understand that there are total 3 key techs behind the blockchain. The very first one is cryptography, or the second is consensus mechanism, and third is P2P networks. So these are the core areas, or we can say core of blockchain. The very first one is cryptography. So in blockchain, we employ some of the tools and techniques of cryptography. For example, hashing is there, then digital signatures we use. So here we can define it as use of public key cryptography and some hash functions which are essential for the transparency and privacy. So we have discussed the features and the certain characteristics of blockchain, and to achieve all those features and the characteristics of blockchain, we are employing these technologies like cryptography, then consensus mechanism. It's a sort of agreement, and we will study different type of agreement in the consensus mechanism. And then P2P network. It means the network is peer-to-peer based. Okay. So second is consensus. Consensus is just like an agreement. So the nodes, the entities who are participating in the network, they must validate the transactions by some set of rules, or you can say consensus mechanism. So some of the consensus mechanism are proof of work and proof of stake. There are many, but these the proof of work is mainly used in the public blockchains. We'll study different types of the blockchains, and accordingly we select the consensus mechanism, and it depends on certain factors, like it also depends on what type of the blockchain we are using. So the next or the third tech is P2P network, that is peer-to-peer network. So every node of the network acts as a client as well as a server, and each entity of the node in the network has same sort of responsibilities, has same part. Each has the updated form of ledger or copy of the record, we can say. So each node of the network acts as a client as well as a server and holding the identical copy of the application state. And that is why we are saying that the nodes who were unaware of each other, they're not known, they are able to reach a consensus, because then only they will be able to validate a transaction. Okay, so this is the first topic. These are the key techs we use in blockchain. And there are certain subheads also under these main heads. Now the second topic is about challenges of blockchain. So we have, I have listed out some challenges. You can add some more also. So the blockchain technology has certain benefits as well as some challenges also. So, but it is not without its flaws. So it has some pros and cons. It suffers from a number of challenges which prevent it from being implemented as a standard applications, and these are some challenges. So the very first one is the high energy consumption. Then we use private key. We'll see that how these are a challenge. Then high cost is involved in the while we are employing the blockchain, and then it's a slower process. Immutability. Immutability is the core feature of blockchain, and it is also an advantage. Simultaneously, some of the features we can use interchangeably. Like they can be categorized into the advantage or disadvantage also. So scalability issue, and the last is inefficiency. Okay. So the very first one is high energy consumption. So Bitcoin was the first currency to utilize the blockchain technology, and it makes use of the proof of work consensus algorithm. So it is it is the name of the algorithm, the consensus algorithm, and it is the very first algorithm which we will study under the consensus. So which places the onus of carrying out all the laborious work on the miners themselves, because it involves some sort of complex problems which need to be solved in order to reach the consensus. And that is why we are saying it is quite computationally expensive, as it requires some machinery to do it. So motivating children, so the teenagers, to solve such difficult mathematical problem is one of the priority in case of proof of work consensus if you are dealing with this. So the high amount of energy required to solve this difficult mathematical problems makes them less ideal for the world, because it involves high amount of energy in solving those complexity problems, but the results will be better in case of proof of work. So here we need to justify the disadvantages. So the very first one is high energy consumption. So you can cite this consensus mechanism and explain accordingly. Next is the private key. So the users of blockchain, they have access to the private key and serve as their own banks. So if a user loses their private key, see, in cryptography is one of the tech which we are using behind blockchain. And if a user loses their private key, in cryptography, we are using digital signature. So there we are employing private keys or public keys concept. So if a user loses their private key, the funds in their wallet will be removed and it will not be possible for anyone to retrieve them. So that is how private key is one of the challenge in blockchain. Next is the high cost. So the high cost of system is contributed to in the large part by the expenses, with the hiring developers or paying the license fees for paid blockchain solutions and performing the routine maintenance. So for performing routine maintenance, or it involves some sort of fees also, it includes high cost. Next is slow process. So it can become sluggish when there are excessive number of users on the network. Definitely, if we have number of entities in the network, it depends on a particular scenario, but if it exceed the capacity, then definitely it will become sluggish. Next is immutability. So it is one of the core important feature, and we are supposed to maintain the immutability, and that is why we are employing the blockchain in most of the use cases also. So in immutability, we are saying that once we are done with the storage, we can't change it. We can't change the data. So it has a number of significant drawbacks. The capacity of blockchain ledger to continue operating without being modified is an example of immutability. So this indicates that we cannot change anything once it is stored to any of the record in any way, and that is how you can justify the immutability is a challenge. Next is so the records will be reversible, so that will not allow you for any changes to be made to it after or once you are done with the data. Then scalability is also one of the issue. So the consensus mechanism, although there are many consensus algorithms, we have an algorithm just like it in a Bitcoin. It is one of the platform. So it is necessary for every entity to perform a sort of verification, and therefore there is a cap placed on the number of transactions. Fine. So by scalability, we are trying to increase the requirement. So Bitcoin was not designed to process the transactions on the large scale when it was first launched. So Bitcoin block size, suppose the block size is 1 MB and the block time is 10 minutes. So at this time, the maximum number of the transactions the Bitcoin handle in 1 second is just 7. So these are some of the factual information you can cite under the scalability, or while you are trying to justify that how a scalability is an issue. Although you can scale it, but there are certain limitations. So Bitcoin scales using the layer 2 solutions. Yes, we have the solution, we can scale it using the layer 2 solutions, but we are talking about the very basic one. like the Lightning Network, which can handle the thousands of transactions per second of chain. So if you're employing layer 2 solutions, definitely you can scale the Bitcoin platform. But generally, or when it was first launched, then the maximum number of the transactions that the Bitcoin handle, it was only 7 per second. So the next challenge is inefficiency. How we can justify that it's a challenge in Bitcoin. So it does not store data in the effective manner. It can result in the storage issues in the multiple or for the multiple nodes that want to join the network. There must be a more effective approach to dealing with this matter. So therefore, nodes should replicate the data at the regular intervals or whenever it is updated, and the entire network will become more sluggish. So it is quite similar to the slower process. It is almost related, or it happens in the scenario when we have excessive number of the users or the nodes in a particular network. Okay. So because of this, it is not suitable for use in the commercial seconds where we require the quick and secure results at the same time. So it is necessary for each node to perform a sort of verification of the transactions. And that is why we always put a cap on the number of the transactions or per second transactions that a blockchain network can handle at a particular moment. Okay. So third topic is the difference between blockchain and database. We are done with the important techniques behind blockchain. And the second topic is the challenges. We have discussed all the challenges which are involved in the blockchain technology. And third topic is the difference between blockchain and databases. We have been discussing database. And we studied database in the second year, and we all are aware about the traditional databases. That what are traditional databases. Now we need to distinguish that how blockchain is different from databases, and there are certain criteria for that. So on the left hand side, you can see it is for this column is for blockchain and this column is for the database, and in between we have certain parameters or the factors on the basis of which you can just distinguish two things. So the very first one is authority. On the basis of authority, blockchain is decentralized. We have covered all the features of blockchain. So one of the important features of blockchain was decentralization. So it is decentralized and has no centralized approach. So there are some type of blockchains, for example, private blockchain, that may utilize some form of centralization. Now the databases are controlled by administrator and they're centralized in the nature. So on the basis of authority, we can distinguish blockchain and this database. Second is the architecture. So here blockchain employ a sort of distributed architecture, and while the database, it simply uses the client and server architecture. Third factor is data handling. So blockchain utilizes the read and write operations, while the database supports crude operations. It stands for create, read, update, and delete. So I hope we need not to discuss all these things. You can just write what sort of operations a particular technology or architecture is using. Then we have integrity. So blockchain has many features for everything, for the security, and it supports integrity also. Integrity means data is same at the receiver end as it was at the sender end. So on the other hand, we have the malicious actors. They can alter the database data. The traditional databases, they are quite less secure in comparison to the blockchain. Definitely, we don't have that much advanced techniques in the traditional databases. Then on the basis of the transparency, so the public blockchains, they offer the transparency, and each node who are participating in the network, they can see the transactions or the data, the updated data. So the visibility is there and transparency is maintained. On the other hand, the databases, they're not transparent, and only the administrator decides that public can access the data or not. Then we have the other criteria, that is called cost. So cost means the blockchains, they're comparatively harder to implement and maintain, and that is why we are saying it includes the high cost. While the database being an older technology, it is easy to maintain and implement. Then the last parameter is the performance. So on the basis of this, blockchain is bogged down by the verification and the consensus methods. There are some consensus mechanism or smart contracts or chain codes as per the platform we are choosing for the blockchain, and some sort of the verification mechanism we followed in the blockchain. And then only we can say that the process is transparent, or the unknown entities on the network, they are able to reach a consensus by following a set of rules. But here, databases are extremely fast and they offers the great scalability in comparison to this blockchain. Okay. So the next topic is history of blockchain, and it is quite theoretical. In this, you just need to remember the names, key finding in a particular year, some years, and the key finding, and that will suffice the situation. So the very first thing is, the technology was described in 1991 by the researchers Stuart and Scott, and they wanted to introduce a computationally practical solution for the time-stamping digital document. So this is important. This is one of the key finding. So you just need to remember the year and the corresponding key finding in that particular year. So the technology was described in 1991, and it introduces a computationally practical solutions for time-stamping digital document. We have discussed we have discussed the components of the blockchain, and one of the component is timestamp. That every time when a record is stored in the blockchain, time is there, and that is how you were able to maintain the records in the chronological order. So that they could not backdate it or tempered, and they developed such a system using the concept of cryptographically secured chain. Every other block is maintaining the hash value of the previous one, and that is how the blocks are chained in the blockchain. So in 1992, we have certain concept called Merkle tree, and we have a component also, Merkle root, in the components of blocks. So Merkle tree were incorporated into the design, and they makes the blockchain more efficient by allowing certain documents to be collected into just one block. So Merkle trees, they are used to create the secure chain of blocks, and they contain the history of the entire chain. So this was one of the concept, Merkle trees, in 1992, and it was introduced to make blockchain more efficient. Next is this is the visualization of Merkle tree. So in this, a Merkle tree can be described as a structure that combines the hash data step by step to produce one final hash called the root hash. So this is the top hash, or you can say root hash. We have two hashes, so they are combined together until unless we are able to reach the top one. So this is how you can just define Merkle tree. It's a structure that combines the hashes step by step to produce the one final hash that is called root hash. Okay, so each data block is hashed, and then pair of the hashes, they are again hashed together until one single hash represent all the data. So this is what is happening in this diagram. These are the hashes, and we are combining the hashes stepwise until we get the top hash or the root hash to represent the whole data at once. Okay, so in 2004, Finney was a researcher, and he introduced this RPOW, that is reusable proof of work, as a prototype for digital cash. So you need to remember the key findings, that RPOW, then Merkle tree was there, then cryptographically solutions were there. So what was the problem? What was the solutions? You need to just remember this. Now, this particular paradigm, it worked by receiving a non-exchangeable or some hash code based proof of work, and they created a RSA signed tokens here, and that can further transfer from person to person. So it solved, this particular concept is able to solve the double spending problem by keeping the ownership of the top tokens. So what is double spending? That you are using the same money you're using the same money twice. So that is the double spending problem, and this particular concept was designed in order to solve this problem, double spending problem. Okay. Now, in 2008, Satoshi conceptualized the theory of distributed blockchain. So we already know that the blockchain is based on, it's a distributed technology, it's a decentralized technology. So he improves the design in such a way to make it more efficient, so he adds blocks to the initial chain without requiring them to be signed by the trusted parties. So he tried to reduce the involvement of the parties, and he utilizes the peer-to-peer network. That is the third category. Third category we have under the text behind blockchain for time stamping and verifying each exchange, so that the blocks, they are arranged in the chronological fashion. So makes the blockchain as a backbone of cryptocurrency, and the design serves as a public ledger. Okay, so we are done with the history of blockchain, and we have seen certain technologies behind the blockchain. And the second topic was the Merkle tree, and we have seen the difference between blockchain and databases. So this is it for today. In the next lecture, we'll discuss what is digital money and what is the journey from the digital money to the distributed ledger.